Hi there, this is presentation one for biochemistry. We were given a prompt that says, explain what the principles are involved in holding two alpha helices together. Suggest one possible residue that can replace leucine as indicated by the red star, and then maintain the hydrophobic core shown below and suggest one possible residue that would destabilize the core. And then we are to explain our reasoning. First off, I want to explain how the helix is made. The alpha helix is a right-handed helix with peptide bonds located on the inside and side of chains. On the inside and side chains are extending outward. It is stabilized by the regular formation of hydrogen bonds parallel to the axis of the helix, though they are formed between the amino and carbonyl groups of every fourth peptide bond. A carbonyl group is a functional group composed of a carbon atom that is double bonded to an oxygen atom. Amines are compounds and functional groups that contain a basic nitrogen atom with a lone pair. In the image on the right side of the screen, we can see that this bond between leucine molecules have a hydrophobic interaction. A hydrophobic interaction is when nonpolar molecules, that usually have a long chain of carbons, come together with water molecules. This hydrophobic interaction allows the molecule to remain stable because the water-hating aminos band together and protect themselves in a roundabout way of saying. We can also see that there is an electrostatic interaction between lysine and glutamate. An electrostatic interaction is the attraction between two completely ionized molecules with opposite charges, aka opposites attract. Um, we were asked that which residue could replace leucine, and I chose that of isoleucine because it is also hydrophobic in nature and is also the same length. A residue that could ruin the stability of helixes would be that of serine. Serine is hydrophilic, meaning those amino acids that once banded together would be tempted to break up and then see other people. Haha, there goes that stable relationship. On this next slide, I wanted to show the electrostatic interaction as seen here. Those opposites are attracting with that positive and negative charge that you can see right here, right there. And then we can also see an example of hydrogen bonding. We've learned this from combining our amino acids together in order to create a chain where the water molecule falls off here. Prompt 2, we were asked to propose a different amino acid pair whose side chains could interact in a similar manner to lysine and glutamate. There are many combos that would be able to interact in a similar manner to these two. For example, histidine and aspartate, I don't know how to say that, I'm sorry. They are also like lysine and glutamate. One amino is acidic and the other is basic. Thanks for watching my presentation. I hope you enjoyed it and feel free to leave any feedback.